Good evening, participants. Am I audible? Is my screen visible? Can you please confirm? Yes, thank you. Thanks for the response. So, today is day 7 of this data science Naan Mudhalvan Virtual Internship, and I welcome you all on behalf of pantech elearning. Did you guys completed your assignment? Did you guys submitted it in LinkedIn or Facebook? So, in yesterday's class, you can find the link for it for updating it. Okay. So make sure you submit it. Today one link will be provided, that is a Google form. So in that you have to update, okay, whether you have submitted the assignment or not. This is for updating the assignment 1. Okay, so in that what you have to do is first you have to, okay, the LinkedIn request will be accepted as soon as possible. So once you got accepted, you kindly submit it. Once you submit the assignment, you'll be posting it, right? So please copy that link, and in this Google form today it will be circulated for updating the assignment. Okay, so in that you have to paste that LinkedIn or Facebook link where you have submitted your assignment. Okay, so that's mandatory. So with that only we can know whether you have submitted or not. Clear? So in tomorrow's class, okay, please try to do this updating and submitting the assignment by tomorrow, okay, before tomorrow's class. So in tomorrow's class I'll teach you how to do the assignment. Okay, so today in day 7, so till now what we have seen the all the basics for the data analytics part. So now we are moving into machine learning part. Okay, so it is an important step, okay, in data science. Machine learning is an important tool, and for the next 7 to 8 days we'll be seeing about machine learning, how to use it elaborately. Okay, so starting with today, okay, today we are going to see about the introduction of machine learning and some of the pre-processing tasks with machine learning. Okay, can we start, guys? Can I get thumbs up in chat box? Can we start with machine learning today? Are you guys ready? So we are going to take enough time and do it elaborately so that we can learn many things. And I hope the assignment 1 update link is available in the chat. So make sure you are submitting the link there. Okay. Okay, so today I'll tell you how to collect the data set also. So first, starting with the introduction of machine learning. So first you have to understand what is the meaning of AI, ML and DL. AI is artificial intelligence, and what is machine learning and what is deep learning and what's their difference actually. So when you go for artificial intelligence, it is mimicking the intelligence or behavioral pattern of human or any other living entity. Okay, it's like it's thinking on its own. Okay, so in that, in artificial intelligence is a collective thing. Okay, and in that a part or a tool can be machine learning. Okay, so machine learning comes into play. It is a technique by which a computer can learn from data without using complex set of different rules. Okay, so this approach is mainly based on training a model from data set and do prediction and stuffs. And then in machine learning there is another part. Okay, part of machine learning is known as deep learning. Okay, so in this deep learning, it is a technique to perform machine learning inspired by our own brain's own network of neurons. Okay, so in machine learning you'll use algorithms, and in deep learning we'll use neural networks which mimics the human brain. So this is what collective artificial intelligence does. So AI is a branch of computer science that is concerned with building smart and intelligent machines So it refers to the simulation of human intelligence, like in all the way human are analyzing, right? So like visual perception, speech recognition, decision making, and language translation, all these tasks. Okay. So regarding machine learning is a subfield of artificial intelligence that focuses on the development of algorithms and statistical models that allow computers to learn and make predictions or decisions without being explicitly programmed to do so. Machine learning models require large amount of data to learn from and make accurate predictions. So till now we have seen using pandas how to load the data, how to analyze it. Next step will be giving it to the machine learning model. So model is something like an algorithm. It is predefined. It will do some statistical thing. Okay, it is like a black box. You will give something. It will do some process and give you the output. And we want to learn about this black box. What inside happening is. So that's what we are going to see. So machine learning is widely used in various industries, including finance, healthcare, marketing, and e-commerce. It is used for tasks such as image recognition, natural language processing, anomaly detection, and so on. And as I told you earlier, in machine learning, we'll use some algorithms. Okay, when you go for deep learning, it uses neural networks. So deep learning is a part of machine learning, some kind of advanced machine learning, you can say that. So it's a subfield of machine learning which is inspired by the structure and function of brain known as artificial neural networks. So in brain we have our neural network, right? So in that similar way, they are trying to create a neural network. Okay, so this deep learning has achieved state of art result in various fields, including image processing, speech recognition, NLP, and game playing, and so on. It is also widely used in computer vision, autonomous vehicles, and recommendation systems. So the main advantage of deep learning is its ability to automatically learn and extract features from the raw data without need to manual feature engineering. When we go for machine learning, we need to select the features, do the processing, and give it to the model. When you go for deep learning, it will do it on its own. Okay, and this is what the structure of a neural network can be. There will be many layers. So we are going to cover deep learning also after we complete the machine learning. So in that time, I'll explain you all these things in detail. Okay, it consists of many neural network, and with that, it will try to give the output, which mimics the human brain. So now comes the question: what is the role of machine learning in data science? All this AI, machine learning, deep learning, how it comes into play in data science? So as you can see, data science composed of mathematics, statistics, visualization, exploratory data analysis, along with the machine learning, deep learning, and the help of AI, we can perform the data science. So what is the role of machine learning in data science? Machine learning can help to discover hidden patterns and relationship in large and complex data set. Okay, so you can find trend and find relationship. It can be used to build predictive models and make data driven decisions. Okay, it can be used to build predictive models and make data driven decisions. Machine learning algorithms can automate and optimize process, reducing the need for manual intervention. It can enable business to gain insight into customer behavior, improve products and services, and increase profitability. So regarding the Titanic dataset, I'll show you how to do it. Don't worry. In today's class, I'll tell you how to download it. So these are the applications of machine learning. So there are many applications including language translation in medical field, stock market trading, fraud detection, personal assistant, email, spam and malware filtering, self-driving cars, product recommendations, traffic prediction, speech recognition, image processing, and so on. So in machine learning, what we are actually doing is we are giving the past data. So we are having some data set. So we have worked with many data, right? Till now in Pandas we have loaded many data and done that. So we are using the data set and we are processing and analyzing and do the pre-processing and give it to the model. Okay. So this is what we are doing in machine learning. So can we start with the types of machine learning? Can we start, guys? Till now is it clear regarding the introduction? So starting with the types of machine learning. Okay. So in machine learning, it is composed of three types. So we can classify them as supervised machine learning, unsupervised machine learning, and then reinforcement learning. So when you go for supervised machine learning, the machines are trained using well labeled training data. Okay, there are labeled training data and we are using it. When you go for unsupervised machine learning, models are trained using unlabeled data. So there is some difference between labeled data and unlabeled data. So I'll tell you what it is when we actually see it. So whatever till now you have mostly seen about the labeled data. For example, the labeled data is something like the machine will know this is the prediction, this is the output, this or that or like that. For example, we have seen some diabetes data set, right? So where the output is our heart data set where we are having a target, okay, either 0 or 1, okay, either heart disease is present or absent. So these are the labels. So it can't, we'll be giving the label separately so that it can give or map the output. So that's what known as labeled training data. So it is comes under supervised machine learning, and there are subdivisions in that. We'll learn that later. When you go for unsupervised machine learning, models are trained using unlabeled data. So here there is no label. So we are going to try to find some pattern or grouping or clusters. So based on that, we are trying to take some actionable insights. And next thing will be reinforcement machine learning. This reinforcement machine learning is a feedback based technique. So it is used in games and so on based on the reward it will do. Okay. So we'll see some little bit inside of the supervised learning. So supervised machine learning, which uses the labeled data to train the machine learning models. So generally, it has some subdivisions like regression and classification problems. Okay, so we are having regression and classification problem. So in classification, we are like it's binary or multi-class classification like this or that, or there is some data set like car data set where we are going to predict either 1 or 2 or 3 in something like that. Okay, so these comes under classification problem. Based on the output class, it is going to predict this or that, or if you give 3 choices, it is going to give you one output based on the statistics of the features. When you go for regression, it is actually like the car data set where based on the features you are going to predict the price of the car. Okay, it is a used car for example. So it can consider if the output is continuous value, okay, then it is regression problem. So if it is discrete, then it is a classification problem based on the output, reliability data. So for example, in regression, you can go with the salary prediction or something like that, where the prediction output cannot be either this or that. Okay, it will be a range of value and a continuous value. It can be a range, something like that. So the data, it is a labeled data and the output is already known. The model just need to map the input to respective output. Okay, based on the statistics. So regarding application, there are many applications, prediction, and so on. When you go for unsupervised learning, it uses unlabeled data, which means there is no separate output here. So what we'll be doing is we'll try to find the pattern and feature in the data and return the output. We'll try to find some clusters. For example, in banking sector or in the marketing, we'll try to find the customer segmentation. There is some project we will be seeing that. And in healthcare with clustering by scan report, some applications are there. When you go for reinforcement learning, it uses to train a machine to take suitable action and maximize its reward in particular situation. So it uses an agent and environment to produce action and reward. For example, in robotics and self-driving cars and in games, this reinforcement learning, which will learn on its own and do the task. Okay, so that's what this reinforcement learning is. So is it clear regarding the types of machine learning? Do you guys have any doubt? Is it clear regarding the types? So we'll once again see about it when we go into deep about the machine learning. This is just a brief introduction. So today our focus will be in the data collection first and then into data pre-processing where we'll see only one or few tools. Okay. So this is our entire machine learning step. Once you complete all this, you will be able to do machine learning project. Regarding the LinkedIn, it will be accepted soon. Once you got accept, you can post the assignment. Okay. No issues with that. You have time till tomorrow, so don't worry. clear regarding till now? Can I get some response? Regarding the Python internship project, if you didn't receive the link, I'll ask my team to contact you as soon as possible, okay? They'll give you some way to submit it, don't worry if you couldn't submit it. I'll ask my team to do it as soon as possible. Okay, so we'll start with the steps in machine learning. Okay, so what are the steps in machine learning? So first thing, we are going to work with data. So first step will be data collection. So if you are having some idea, or you want to, for example, you want to perform data science on some task, okay, and you are going to use machine learning as a tool for it, okay, you are going to use machine learning as a tool for it, and what you have to do is the first step, you want to find the data regarding to it similarly, okay. So first, once you collect the data, then will be the pre-processing part, where we'll be using Pandas, NumPy and Matplotlib Sequent for the exploratory part. Okay, you can do certain pre-processing with Pandas, but when you go for machine learning, okay, we have to go to the model and we have to submit all the features we will be having. The data you have to pass it to the model. So before giving it to the model, you have to pass these three steps. The first one will be pre-processing. So there are many things you have to consider, because in machine learning model you cannot give as such all the data, it will give you improper prediction, okay. So if you want to have some accurate prediction, what you have to do is you have to do pre-processing. So there are many things you have to check. Once you check all those things, you have to perform feature selection, which is important, which columns you are going to give to the machine, okay, you want to finalize it. And there is something known as train test split, we will see that later, which is nothing but, if we are having 1000 rows, okay, in our data set, we'll be splitting, okay, we'll be splitting them for like 700 rows. I'll give it for the training part, and there is something known as testing, where I'll be giving the remaining 300 to the model to evaluate itself. So that steps will come under this prediction and evaluate and improve. So if the prediction is low, then you want to like change all these things to get high prediction. You can get a score of it, okay. So the last date for assignment submission will be tomorrow. So make sure you complete it before that. So we are going to see about data collection. I'll show you with Titanic dataset how to open it or download it, okay. Is it clear regarding the steps in machine learning? First data collection, then you have to perform pre-processing, then feature selection, then train test split. You have to split for the training and testing. So next step will be model. So you have to select some model based on the task or the data you are having, what you are going to do. Okay, then you have to do the training part, then you have to do the testing or prediction, and you want to evaluate, and if you want to improve, you have to repeat these steps to get some high accuracy. So once you complete all these things, you can get some output in the end. Okay, this is the steps in machine learning. So starting with data collection, can we start, guys? Can I get thumbs up in chat box? Can we start with data collection? How to do it? So for data collection, when you, like for example, if you are working in a company, okay, so in most of the cases the company will buy some data, and or they have some their own data where you will be performing data science, where you will be doing some processing to the data. Okay, so but if you want to perform in this level, okay, if you want to try to do the data science or machine learning, how will you collect the data? So there are some already available datasets you can check. So these are the websites for downloading the dataset, and you can create your own dataset also. I'll talk about it later. So how are you going to collect some data? For example, if I'm having an idea, okay, to perform data science or machine learning in, for example, the Titanic dataset. So I want to analyze the data, okay, for example, based on the Titanic, or for example, if I need to go with some disease, I want to predict it for like COVID-19. I want to get some data and I want to check how it is the trend, how had or what happened, okay. So these are some common websites where you can find the data sets. For example, the name Kaggle. So this Kaggle is a website, okay, it is a machine learning place where many like data scientists and machine learning engineers are there. So there will be some competitions and data sets also, you can download or see it, okay. So first I'll go into Kaggle. Please note down of it, kaggle.com. So here you want to create an account with your mail ID. Okay, then only you can download your dataset. So here you can go and see the dataset. Okay, so there are many datasets available. You can search your own dataset also. For example, if you want the Titanic dataset, see here I'm searching for Titanic. Okay, so you can apply the filter. See here I got the dataset. So I can go into any of this and check which dataset is suitable for me. Okay, here there is some dataset. Okay, so you can see all the column names here. Okay, there are 28 columns and all these things are there. This seems like some not good dataset. You can use the filters, sort by, okay, and get some good dataset. Once you got it, you can download it here. So if you want this dataset, then I can go and click this option. If you want to download it, you have to create an account with your mail ID in this Kaggle. Then only you can download it. So this is going to give me a zip file. It will download, ask me the location and it will download. This is the Kaggle, regarding Kaggle. And then there is something known as UCI machine learning repository. So this is also a place where you can find the many datasets. UCI machine learning repository. Okay, so this also contains many dataset collection where you can find many dataset and you can download it. Okay, and regarding the next one is nothing but the Google dataset search. So this is a search engine for dataset search. If you type keyword, it is going to show you what are the relevant datasets available in Google. Google dataset search. Okay, for example, if you want to get about diabetes, so this is going to give me what all available. That include Kaggle link also. Okay, this is 10 years diabetes dataset, and this is from Mentally. Okay, this is Indian diabetes dataset. Okay, there are many datasets available. You can go and check the link and download it. So this is how you can search for some pre-existing dataset. Other than that, you can check in Google also. You can randomly check, and if you find, very good. So these are the most common three. And regarding the datasets, if you want to create your own dataset, how are you going to do? Any idea how can we create our own dataset? So some of you guys have attended the previous Python internship, right? So where we have seen some tasks or tool with Python. With that you can create your own dataset. Remember guys, anyone there? What is the way to create your own dataset? From internet, what all available, you can collect it. What is the method for it? What is the name for it? Any idea? It is from Python, with the help of Python. Okay, it's nothing but web scraping. So with the help of Beautiful Soup or Selenium Python, okay, you can go and search. For example, like if you want to learn about it, we have took it in previous class in the Python data science Naan Mudhalvan internship. Okay, in this YouTube channel, in the playlist you can find it. And in day 11 I have took about, yes, using survey you can do it also. Using web scraping, in day 11 I have took about web scraping. Okay, for example, we have done with IMDb website. Based on the movie, I got collected some data. It is nearly 1000 movie names along with the rating and the year of release and something like that. Okay, or you can check and learn about it. So if you are finding some websites where the scraping is allowed, and if you want, you can take the data on your own and do the pre-processing and do machine learning stuff. Okay, so that's how you will go with the data collection. So we have completed the data collection part. Can we continue with next one, the pre-processing? Can we move on to next one? Is it clear regarding the data collection? If you want to learn about web scraping, you can check. Okay, day 11 of Python Naan Mudhalvan internship. I have took it. It's in the YouTube in pantech elearning channel. You can check it. Okay. So the next will be the pre-processing tools and then the remaining things. For example, feature selection, train, test split, algorithms, model. So for all these things, how are you going to use it? To take these things, there is a library available that is nothing but scikit-learn. This is a famous machine learning library, okay, for performing these tasks with the help of this library scikit-learn. So when you go for scikit-learn, it is also known as sklearn. It is a popular open source machine learning library in Python that provides a wide range of tools for data analysis, model and evaluation part. Okay, it's built on top of NumPy, SciPy, Matplotlib and support integration with Pandas, which makes it easy for the data science workflows. And sklearn is widely used in data science community for various applications in all the parts. Okay, and for the installation, you have to go with pip install scikit-learn. So this is important. Once you install it, you can use it. And scikit-learn is a very vast library. So whenever we need some tools, we are going to import that part alone. Okay, we are not going to import the entire sklearn. We'll be taking it whenever we need. We'll take that alone. Okay. So from sklearn import. So in pre-processing, so now we have completed the data collection. The next step will be data pre-processing. So with Pandas, there are some tools to check the null value or do some tasks, okay. But when you go for machine learning, you have to do these things: feature scaling, encoding, imputing null value, and outlier detection and handling. Okay, these four things will come majorly in pre-processing. So how to do it with sklearn? Okay, so the first thing will be feature scaling. So why we need to do it? So we'll try to complete the feature scaling and encoding in today's class. And regarding the imputing null value and outlier detection and handling, we'll see both of this in tomorrow's class fully. Okay, so starting with feature scaling. So feature scaling is a method used to normalize the range of features of the data. Okay, so features is nothing but the columns. Okay, for example, we have seen the iris dataset, right? In yesterday and previous days class, we have seen the iris dataset. Okay, where we got many things like sepal length, sepal width, petal width. Those are numerical values, and is a method used to normalize the range of features of the data. So the features are nothing but the column names which you are going to use, and they will be in different scale. Okay, and to normalize the range of features, we are doing this feature scaling. So it modifies the value, and we are going to use some methods like normalization or standardization. So these are very important terms. So why we are doing this actually is it helps to avoid bias in machine learning model. So what is this bias and why we are doing it? Feature scaling. Features are the columns which contain numerical data. And for example, I'll tell you with a practical example. So this is a data set. See here, I'm having three columns: age, weight and length. Can you see what is the unit they are measuring? So this is measured in years. Okay, age is measured in years, weight is measured in kilogram, okay, and length or height is measured in centimeter or inches, for example. So all these features, these are features, and they are different in, like, they are measured in different scale. But when you have it in a data set, you will be having only the numerical value. So this age will be in like 2, 3, 4, 5, 6 in that range, and this is going to be in this order 12, 14 or like till 100, and the length will be go above 100 also, right? In centimeter it will go till 170, 180 normally. So all these things are in different scale, but these are numerical values. We are going to do something statistics with the help of machine learning model, but if you don't do the scaling, all these things will be in different range. So what may happen is, okay, when the data set has numerical features and each of them are in different scale, machine learning model can put weight on a feature with larger scale. Okay, for example, see here, this is the largest value, right? This is in like 2, 3, 4 in that range. This is from like double digit, this is single digit, this is double digit, this is triple digit. So this will be a larger scale, so the machine will imagine, okay, or it will understand this is the important feature. So it is going to put a weight on it, okay, it should be avoided. All these features should be equally taken. So for that, we are going to do the scaling, which helps to contribute all the features equally. So if you scale it, okay, we are going to do something known as scaling, where we will be performing something known as normalization or standardization. So it will change all these values based on some statistics. So with that, okay, if they are in normal scale, we can give it to the machine learning model and do further processing. So regarding normalization, as I told you earlier, we are doing something known as normalization or standardization. So going into normalization. So it is a method of scaling the data by fitting the data points between a range of 0 to 1. So if you do this normalization, your data, all these values will be having a range between 0 to 1. Okay, so it won't go like below 0 or above 1. So in that way we are going to transform this. So how we are doing it? So there is a particular module for this to do it, but what is the math or statistic behind it? So what will happen is, the new value how we are getting is, for example, see here, we are taking this column, okay, we are having this 5 years, so I'll be having the 5 here. So minus, what is the x minimum? In this column, what is the minimum value? 2, okay. So we'll be subtracting it with 2 and divided by the maximum minus minimum value. So in this column, what is the maximum value? 12. What is the minimum? 2. So when you perform this, you will be getting a new x value which will be in the range of 0 to 1. It won't go about. Okay, you will be doing it. For example, I'll take this and do the task and place it here. I'll take this, do the task, place it here. Similarly, I'll do for all the columns so that it will be scaled equally. Okay, that's what the normalization will do. It will convert the points into a range between 0 to 1. And how to perform it? So from sklearn, you can import this min max scalar, which is a minimum maximum scalar. So you can set the scale also. For example, if you want to scale it between 0 to 10, you can do that by mentioning the scale here. By default, it is going to give you from 0 to 1. So from sklearn.preprocessing, import minimum maximum scalar. So I have to create an object for it. Scalar is equal to minimum maximum scalar. Okay, this is a class. You have to create an object for it. Once you create an object, you can access the functions inside of it, which is nothing but fit underscore transform. So this option fit underscore transform, what it will do is, it will take the values, okay, it will take the data set, it will do this task, okay, it will do all these tasks and place these points here and then give you, transform it and give you the output. Clear regarding minimum maximum scalar? Regarding normalization, is it clear? Can we see a practical example? Can we see a practical example? Okay, so I load some data set. Okay, it is a wine quality data set. You can download it from Kaggle. So I am not going to give you here after the data set. So as we know how to, like I taught you right how to download data set, you can search and download it from Kaggle. Okay, so I'll import the necessary libraries. Import pandas as PD. Okay, data equal to pd.read underscore csv. So first we'll see about this normalization. Okay, so we are going to do the scaling part. Why we are doing? Because we want to convert them into a single scale. Okay, since they are in different scale, I don't want the machine to put the bias on it or wait on one feature which has larger scale. So this is the data set we are having and it is having many numerical values, right? So I'm going to take this column for example. Okay, so I'm going to do, like these are having these features, right? So I'm going to scale this. So for that, what I have to do, from sklearn.preprocessing, import min max scalar. See here the capital M scalar, so it is important, otherwise you will be getting error. So I create an object for it, scale equal to min max scalar. Okay, and what I am going to do is, I'll store it in x equal to, call this scale to dot fit underscore transform, and I'll pass this column here. Okay, for example, I am showing you what is happening behind it. We are fitting and transforming it. Okay, so we got an error here. Okay, you have to pass it like this. Now I hope it will be fine. Yeah, now clear. So I'll print x. Okay, and see here, all these things, okay, it will be scaled in between the range 0 to 1. Okay, it will be between 0 to 1. So the maximum value can be 1 and the minimum value will be 0. So that's what this minimum maximum scalar will do. Okay, clear regarding normalization? It will take that point, it will subtract it with the minimum value of that column, and it will like divided by the maximum minus minimum value of that column. So this is going to give you a value which is between the range 0 to 1 for all the points. Okay. So next thing will be standardization. So compare with normalization, there is something known as standardization here. So what is this standardization is? This converts all the data points to have a mean value of 0 and standard deviation of 1. Okay, what is the mean value? Mean is the average, right? So standard deviation is the calculation where how the value is deviated from the middle value or mean value. Okay, so we can do the standard deviation calculation. So based on this, what we'll do is the new point you will be getting, right? Okay, the new point you are getting. So I'll tell you what is the use and why or when we need to go for normalization or standardization. Now listen. So the new point you are getting, which the actual point minus the mean value divided by the standard deviation. When you perform this, you will be getting an output. Okay, this output will be having a mean value of 0. Okay, this output, when you like finally got the column where you will be having the mean value. For example, if I have the mean value, when I scale using this standardization, okay, it is going to have a mean value of 0 and the standard deviation will be 1. Okay, 1 by 1 it is going to be separated from the middle value. So it is going to convert them in that range. Tell me guys in chat, what will normalization do? It will range them between, tell me in chat box, the normalization will do convert them between 0 to 1. And the standardization, what it will do? It will convert the data points to have a mean value of 0 and standard deviation of 1. Okay, a mean value of 0 and standard deviation of 1. So how are we going to achieve the standardization? So from sklearn.preprocessing, in preprocessing we are going to import standard scalar. So it is the same, you can pass it in this, you can create an object for it and call the fit underscore transform to convert it. Okay. So I can do it in the same here. So instead of minimum maximum scalar, I can import standard scalar. Okay, so I can pass it here. Standard scalar. From sklearn.preprocessing import standard scalar. So I'll fit and transform it. Okay. Now the value see here, it is not from 0 to 1, it has been changed. So what will happen is this entire column now, it has been given, okay, a mean value, it is converted in a way so that it can have a mean value of 0 and standard deviation of 1. Okay. So the next thing will be, so I'll tell you what is the use case when to use it. Please understand now. So next thing will be robust scalar. Okay. For example, so when are we going to use this robust scalar? I'll tell you. In your data set, the last date for assignment will be tomorrow. In robust scalar, what is this robust scalar is? Like normalization and standardization. There is minimum, maximum scalar, standard scalar, right? Similarly, this robust scalar is there. So when your data set is having a number of outliers, okay, when you have large number of outlier, you cannot go with standard scalar or minimum maximum scalar. Why? Tell me guys. Can you understand why? If your data set is having extreme outlier, okay, and why you could not go with standard scalar or minimum maximum scalar? What is the logic behind it? Please try to understand. If you know about this standardization or normalization, you can answer this question. So what is this? For example, when you go for normalization, what it is doing, it will try to find the largest value and smallest value, and based on it, it is performing and manipulating the points. For example, if you are having an outlier in this, for example, instead of 12 years, you are having something known as 120 years, which is actually an outlier, which is very much deviated from the original value. Okay? Imagine instead of 12, you are having 120 here. Okay? So this 120 is an outlier. Okay? And imagine if you are performing normalization. Okay, if you are performing normalization, it is going to subtract all the points with this and convert the point, so it will become very extreme and it won't be not useful at all. Okay, it will transform the data into useless. Clear why we don't go? If you have outlier, you have to handle it, otherwise you cannot go with normalization or standardization. Similar case in standardization, you are going to take the mean value. If I am having a value which is in 120, for example the year is 120, okay, if you scale it, okay, if you go with standardization, it is going to take the mean value, which will obviously affect it. Okay, it will affect the standard deviation and mean. Okay, so the values will become useless. So if you have outlier, you shouldn't go with standardization or normalization. Then in that case, you have to go with this robust scalar. Okay. So this uses interquartile range so that it is robust to the outlier. So we have seen in yesterday, right, how to find the outlier. So with this IQR, okay, we are going to convert this. This robust scalar will convert based on the IQR. How? If you are having outlier, imagine these are the points, okay. So this is how IQR is found. Interquartile range from Q3 minus Q1. Q3 is the 75th percentile. See here, this is the 75th. This is the middle value. Q2 is the center one. Q1 is the 25th percentile. Okay, so it will subtract and give you the IQR value. So each value, the new value is determined by taking the like that element minus the median value of that column, okay, divided by the IQR. Okay, in simple terms, I'll tell you once again. The standardization is something like, or first normalization. It is going to convert the points between 0 to 1. So actually when you convert it, when you see it, all this value will be 0 to 1. It will be between 0 to 1 only. Okay, not more than that. So how we are doing it? You take, okay, for example, take a screenshot of it, take this column and perform this task. X is this value. For example, you have to take 1 by 1. Okay, this is the minimum value, it is 2, and the maximum value is 12. Okay, when you go with this, do this task, plot this like these 10 rows, okay, you can get a value which is between 0 to 1 only, not more than that. And when you go for standardization, okay, we are taking the mean value and standard deviation, and we are subtracting from the original value divided by standard deviation. So this will give you, okay, this will be in a range where the mean value of that column will be 0 and the standard deviation will be totally 1. So in that range we are converting it. And what is the use case, I'll tell you. But when you are having outlier, you cannot go with standard scalar or minimum maximum scalar, standardization or normalization. You have to go with robust scalar, which uses interquartile range. Okay. And to take robust scalar, you can go from sklearn.preprocessing, import robust scalar, and you can create a scale for it and create, you can create an object for it and do the fit underscore transform based on the outlier. Okay. So the next question, which is better? When you should go for normalization or standardization or robust scalar? These three are most common in the scaling part. Feature scaling. We are seeing about feature scaling in the pre-processing, feature scaling, and in that we have seen about normalization, standardization, robust scalar. And which is better, when to go for it? So the normalization will be better when useful when the data doesn't follow Gaussian distribution. Okay, if you are having a column, you can use Seaborn, okay, to perform a plot or histogram where you can see the distribution of the data set. So what is a Gaussian distribution or normal distribution? So the graph will be like this one, okay, like a bell-shaped curve. If you find it, it is a Gaussian distributed data. If your data is Gaussian distributed, then you have to go with standardization using standard scalar. Okay. If your data doesn't follow Gaussian distribution, you can go with normalization. Like if it is random and you want to perform, you can go with normalization. And it is also useful in algorithms like KNN. So we'll be seeing later about KNN, which is a cluster. Okay, it is an algorithm. And then in neural networks, where primarily you want to give the data between 0 to 1, so you can go with normalization. If your data is following Gaussian distribution, you can go with standardization. Okay. Finally, robust scalar. So robust scalar is when your data has outliers. Okay. Since we are covering many things in this 20 days, I have to go in this space. So if you are having any doubt, you can interrupt. Please tell in the chat box. I'll try to clarify if you have any doubt. Okay. Is it clear when to use this normalization or standardization or robust scalar? So when you go with these algorithms, you can go with normalization, or in most cases it is better to go with standardization if your data doesn't have outlier. If you have outlier, you can go with robust scalar, which takes the quartile, and based on it, it is going to convert the value, so it won't be further deviated. If there is outlier, it is going to not affect much. That's what the idea behind this. So next thing will be label encoding. So we'll see this in tomorrow's class. Okay. Do you guys have any doubt? So regarding label encoding, we'll try to see it in tomorrow's class. Okay. It's almost time. So Gaussian distribution is like if you plot all the data. Okay. If it is in the shape of a bell-shaped curve, you try to plot a column in the histogram. Okay. If you got a histogram and if it is in a bell-shaped format, then it is going to be a Gaussian distribution. You can check about it in internet. Okay, regarding standardization, so it is going to convert all the data points to have a mean value of 0 and standard deviation of 1. For example, z equal to x minus mu by sigma. So this is the standard deviation. You are going to divide by it. You are going to have a mean value which you are going to subtract with the x. So what will happen is, see here, if I take this column, okay, in this column it is going to take a mean value. Okay, it is going to take a mean value and then it is going to take a standard deviation. So with this mean and standard deviation, this one and this one, what it will do is, first it will take this one, subtract it with mean and divide it by standard deviation. It will place that value here, and then take this one, it will subtract it with mean and take the divide it by standard deviation and place it here. So like that it is going to do all these tasks here. So once you complete it, if you take and check the mean value, it is going to have all these columns will be having a mean value of 0, and the standard deviation, now if you check it, it is going to be 1. Okay. So the core concept behind why we are doing this is, as I told you earlier, all these numerical things, when you go for machine learning, we are going to give it to the model which is going to do some statistical things and give you the output. That's what the idea behind it. When you have different columns, on all these numerical columns, when they are in different scale, for example, this age is in years, it is in 2, 3, 4 and so on. It is a single digit one. When you go for weight, it is in double digit. And when you go for this height or length, it is going to be in triple digit. So this value is the maximum or biggest value, right? So when you give this to the machine learning to do processing, what it will actually do is, it will consider this as the important feature because it is the highest value. Okay? So when you do it, it is going to give a bias or weight over this, which is not good because you want to consider these features also. So in that case, we are going to do scaling entirely so that it will be either, if it is a normalization, it will be between 0 to 1, or if it is standardization, it will have a mean value of 0, okay, and it will have a standard deviation of 1. Or if you go with robust scalar, it will do based on the interquartile range, so that the outlier won't affect it. So we will be finally having a converted values which will be in mostly decimal points. So when you now give that to the machine learning model, there won't be any extreme features or bias for the machine to put weight on it. Okay, it will be equally contribute all these features. Clear? Regarding what is the core concept behind doing normalization or standardization or the scaling? Why? And for this, there are some other complex things known as Euclidean distance also. So what is the distance between 2 points? Okay, all those things will be much more complex. So for this level, this thing will be very fine. Clear? That's it, guys. Thank you. Thanks for watching. We'll see you in tomorrow's class. We'll see encoding, and then we have to cover like outlier detection and handling. Okay. That's it, guys. Thank you. Thanks for watching.